how to find the coordinates of intercept. So if you are given an equation of a function, it will be very much easy to find the coordinates of the intercept. So looking at these functions that we have here, we have two functions on the same graph. So it's a function of f and also a function of g. So now the question asks us to find the coordinates of a, b, c, and d. But all these coordinates of a, b, c, and d are what we call intercepts. But remember, you must know what intercept is which point. For example, if you want to find the value of c, finding the value of c, we need to identify now this is a point on what? On the function of f. Okay? And then this point is also touching the y-axis. So that means that point is our y-intercept. So now, remember, firstly, you check at the function which this point is. So we said this function, this point is at this function which is f at x. And then the equation for f at x is given as minus x squared plus 4. So let's say now we want to find the coordinates of c. We have realized that c is a y-intercept. So you're going to say now, for y-intercept, remember we let the value of x to be 0. But now this y-intercept, which is c, at which graph is it? It's at the graph of f at x. So but now the graph of f at x is given as what? It's given as f at x equals to minus x squared plus 4. So remember now this f at x here, it simply means y. It's a function. So the equation can be written as what? Y equals to minus x squared plus 4. So now c is what we call the y-intercept. And then for y-intercept, we let the value of x to be 0. So now if we want to find the y-intercept in this case, we are going to substitute the value of x at 0. So you're going to say we have y equals to minus x, but now this x will be replaced by 0. So it's going to be 0 squared plus 4. And then now we find this y-intercept to be how much? To be positive 4. So this will mean now the coordinates of c is going to be what? Where x is 0, y is 4. Because now c is what? C is our y-intercept, and then is the y-intercept of our f at x function. So that means now, firstly, we have solved that, okay, the coordinates of c is 0 is to 4. So let's say, for example, now we want to solve the coordinate of d. Okay, so what do we do first? We need to look at what is d. So d now, we can clearly see is touching the y-axis. So this means d is the y-intercept. But now, at which function is this point d? So this point d is on a what? On an exponential function, which is the function of g at x. So for us to find the coordinate of d, we must find the y-intercept on the equation of g at x, because the point is lying on g at x. Okay, so now how do we do that? We're going to say now, we can see now d is the y-intercept. So we are going to look for the y-intercept. So for y-int, remember the value of x equals to 0. So but now this point is on the exponential function, which is the function of g. And then remember the function of g is given as 1 over 2 all raised to the power of x minus 4. So remember, g simply means y. So you can just write it nicely for yourself so that you don't get confused. So it's going to be 1 over 2 all to the power of x minus 4. So now we have to find the y-intercept. And then when we want to find the y-intercept, the value of x is 0. So we're going to substitute where we see x 0. So we're going to have y equals to 1 over 2 all to the power of 0 minus 4. So but now remember, anything raised to the power of 0 is 1. It is not 0. Please remember, you put everything that you want to solve in a calculator so that you are sure. So now, everything to the power of 0 we know is 1. Then we have 1 minus 4, which will give us the value of negative 3. So now, if the value of y-intercept of d is negative 3, that means it has the coordinates of what? The coordinates of d will be what? Because now the x value is 0 on the y-intercept. we also know that the y value is going to be the value of the intercept, which is 3 in this case. Okay, so we have calculated now the value of what the coordinate of D to be as 0 is to minus 3. So let's say, for example, now we want to find the coordinate of A. So if we look at A here, A is actually a point on the two functions. You see now, A is a point on G at X, which is the red line, and then also is a point on F at X. That means it's a point that is touching both our functions. Okay? So if we want to find the what? The x-intercept of this point, which is point A, you can use any equation that you want. Okay? So now, if you want to find the intercept of A using the graph of G, you will use what? The graph of G. But if you want to find the coordinates of A using the graph of what? The graph of F, you will use the graph of F. But remember now, the graph of F is a quadratic function. So that means if you use the graph of F, you're going to get 2x-intercept, which is the intercept of A and the intercept of B. So by using the f at x, that means you're already solving the coordinates of A and the coordinates of B. So let us use the f at x equation to find the coordinates of B and the coordinates of A. And then we will confirm now the coordinates that we find for what? For G at x. Will it be the same coordinates as A? Because now A is the point on G and also the point on F. So let's say now we want to find the coordinates of A and B by using the graph of what? Of f at x. So you're going to say now, the coordinates of A and B, these are touching what? The x-axis. So we know if a point is touching the x-axis, that is called an x-intercept. And then if we want the x-intercept, we always let the value of y to be equals to 0. So now we are using the function of f, which is a parabolic function. Remember, the function is given as what? F at x equals to minus x squared plus 4. So if we want to find this x-intercept, we're going to let the value of y to be 0. And then remember, this whole thing here is the same thing as y. So that means now, where you see y, you can just put what? 0 equals to minus x squared plus 4. So that you can solve the coordinates of what? Of the x-intercept. And then now we're going to transpose 4 to the other side. So this is going to be minus 4. Then we have minus x squared. So if you want to solve for x, you can divide both sides by -1. So you're going to have 4 here equals to x squared. But remember, you're not looking for x squared. You're looking for the value of x. So you're going to introduce the square root on both the sides. So if you introduce the square root, remember, you always have what? Plus or minus on your answer. Okay? So now if you put now the square root of 4 in your calculator, you get that the value of x is going to be 2, or the value of x is going to be minus 2. So in this case, you have to look now, where is the point of A? We can clearly see now the point of A here is on the negative side of what? Of the x-axis. So that means now the coordinate of A is going to be this one that is having the x value as negative. So the coordinates of A is going to be what? -2 is to 0, because now that is the x-intercept. The value of y there is 0. And then also now the coordinates of point B, the coordinates of point B is going to be what? Is going to be 2 is to 0, because now we can clearly see now B is on the positive side of the x-axis. So the coordinate will have +2. Okay, so if we use this method, we already solve the coordinates of A and the coordinate of B at the same time, because that is a quadratic function. And in a quadratic function, when we solve for the x-intercept, you always get 2x-intercept. So let's write the points that we have now. We have the coordinate of B to be 2 is to 0. And then we also have the coordinates of A to be -2 is to 0. So let's try to use now the g of x to see if we'll find the same coordinate for the point of A. Because now the point of A is touching both the function. It's touching the function at what? At A for what? For the exponential, and then also for the quadratic. So if we look at this exponential graph here, we see now this point is also the x-intercept. So but now if we have the x-intercept, what do we do to find the coordinate of the x-intercept? Remember, we just say now for x-intercept, we always make the value of y to be equals to 0. So what is the equation for g at x? Because it's a point on what? On g at x. So you're going to say g at x is given as what? Is given as 1 over 2 all to the power of x minus 4. So now we are going to substitute now the value of y as 0. But remember now, this g at x is the same thing as y. So that means now where we see g at x, we can put 0 because we are looking for the x-intercept, and then we know the y value is 0. So you're going to have what? 1 over 2 all to the power of x minus 4. So now what we have to do, we have to solve for the value of x. We can take this negative 4 to the other side. So it's going to be positive 4. And then now this half here, we can write it in a what? In a reciprocal way. So that means if you have 1 over 2, you can write it as 2 to the power of negative 1. Okay, so this will be 2 to the power of negative 1, but now it's all raised to the power of x. So if you have an exponential function, remember now, you want to make the bases to be the same. But if you write 4 as a base, you're going to say now 4 is what? Is 2 to the power of 2. So now if you simplify on this side, the exponent will multiply with the exponent there. So you're going to have 2 to the power of negative x. So if you equate the same base, remember you can drop the base and then you equate the exponent. So now what we are going to have is going to be what? It's going to be 2 is equals to negative x. But now if you want for the value of x, you just have to divide by negative 1 on both sides. And then now we find the value of x to be what? To be negative 2. So remember now, this negative 2 is what? Is the x value of what? Of that coordinate, which is the x-intercept at point A. So that means now the coordinates at point A is going to be what? It's going to be negative 2. But remember, because it's the x-intercept, the value of y is 0. So it's negative 2 is to 0. So we can clearly see that whatever equation that we use on the point of A, we'll always find our coordinate to be negative 2 is to 0 for both the condition. So that is how we find the coordinates of the intercept if we are given the equation. Thank you very much.